All right, so absolute extrema on infinite intervals. This actually goes back to characteristics from Algebra 2. And if you remember, if your degree is even, your end behavior is the same. If your degree is odd, your end behavior is opposite. Remember? So if it's even, both ends up. Even positive, if it's even negative, both ends down. Then you have like this and this. I mean, it just, so you have to remember, it doesn't matter if you're sitting at your desk and you're taking a quiz and you go like this, or you go like this, like this, you need to remember what the end behavior is, and it's based on the degree and the leading coefficient. So sometimes your polynomials will not be given to you in standard form. So it's extremely helpful if you write them in order. And if I'm not mistaken, number 53 from your homework was not in standard form, and I'm going to show that someone asked about it. So I think negative x cubed was at the very end, so you needed to really rewrite it. And this kind of leads up to that same idea, so when I go through that, it might make a little bit more sense to some of us. Okay, so in this case, what we're looking at here is if we're looking at the highest degree and you're evaluating the limit, so you're looking at the end behavior, that's why it's a limit of your function as x approaches negative infinity, and it's saying that your y value goes to positive infinity, and then on the other side, as x is approaching positive infinity, your y values are going to positive infinity. So this is the graph that would represent that, and basically what this is you have a positive leading coefficient even degree function. That's what that means. Okay, think about like the easiest one that we could do, x squared, right? A quadratic. Okay, if you have positive x squared, you know the graph goes like this. Negative x squared, the only difference is they flip down, right? So then that's the same idea here. If you have the limit as x is approaching negative infinity, and your one side, your y value is heading towards negative infinity, and then on the other side, as x is approaching positive infinity, your y value is still heading towards negative infinity. So what this is a negative leading coefficient even degree function. It could be a fourth degree, it could be a sixth degree, it's just an even degree. The end behavior is the same as a quadratic. Okay? Here, what they're saying is the limit as x is approaching negative infinity, meaning my x values are getting smaller, my y values are also getting smaller. But then on the other side, as x is getting larger, your y values are getting larger. So this is a positive leading coefficient odd degree function. Think about x cubed. That's the most basic, I mean, even a linear function, x to the first power, right? That's even easier. So then here, if you have the limit as x is approaching negative infinity and your y value is getting larger, as x is getting larger, your y is getting smaller, this is a negative leading coefficient odd degree. Okay, so there are some things here. In this case, you're not going to have an absolute max or an absolute min because these graphs are going to continue on in either direction. And again, that's why I like to use either a linear function. I mean, think about it. Y is equal to negative x, right? You have a slope instead of going like this, it goes like this. Think about the end behavior. Y is equal to x. I mean, that's the easiest one. Or even x cubed is the same, right? Same idea. Just sketch the graph. It doesn't matter what's happening in the middle. What we care about is what's happening on the end. Okay, so if you have an even degree function, you're either going to have an absolute max or an absolute min. But with these, you're not going to have either because the graph will just continue on in either direction. So when you're taking a look at a problem here, it says find the absolute max and min values of this function on a given interval from negative infinity to positive infinity and state where those values occur. The first thing you need to look at is, okay, I don't have a finite interval. I don't have a closed interval. And my graph is going to go on and on and on in either direction. So I need to figure out, first of all, am I going to have an absolute max or an absolute min at all? And this is going to be based on the degree. So when I look at this function here, we have what kind of function out of all of these right here? First, second, third, or fourth? It's the first one. This is a positive even. Okay, so what that means is I am definitely going to have an absolute min. Okay, so with the even degree, basically what we would do is, knowing that we're going to have an absolute min, we just need to make sure of that, okay, and we would need to test it, just like we did for the absolute extrema on the previous problem, okay, but now we're just looking to make sure that it's a small value. Everybody good? All right. So what you do is you take the derivative. Okay, so this is 4x cubed plus 4. Okay, so how would I deal with this if I'm going to set it equal to 0? I'm looking for a candidate, because negative infinity to positive infinity, those are not candidates, right? I cannot plug those in. I need something to plug in so I can have a point. So what do? Factor out the 4. All right, we've got 4 times x cubed plus 1 is equal to 0. Do you guys remember how to factor cubes? Okay, some of you are going to do SOAP. Okay, I'm going to do what's called SOPs. It's how I taught it. It's the same thing. It's the same. Don't give me she just gives me a crazy look like, girl, it's SOAP. Okay, so this is what you've got. 4. This is a binomial times a trinomial is equal to 0. Okay, if you like SOAP, you do SOAP. Let's see if we get the same answer. Okay, how do I get what goes in here? Yeah, it's the cube root of both of those terms, right? So it's going to be x plus 1. Here is SOPs. This, and this. This means square the first term. So it's x squared. OP means opposite of the product. So what is this? What's 1 times x? What's the opposite of that? Oh, look at that. Negative x. And then this means square the last term. So what is this? Plus 1. Okay, if you did SOAP, you should have gotten the same thing. I think this here means the same. Opposite, yeah. It's the same. Yeah. Okay. So, now that this is factored, this is not a candidate. True or false? True. Okay, it's just 4 equals 0. That's not even a true statement. Okay, so what's another candidate? X equals negative 1. Question. What do I do with this thing? 2 factors of 1 that add up to negative 1. Nothing. Okay? How do I test to see if I have any real answers? What do I use? Starts with a D. Discriminant. Oh, yeah, I was going to say that. Okay, don't bet all your money. Okay, discriminant, remember, is b squared minus 4ac. Why does that help me? Okay. What? Yeah, it's from the quadratic formula, and it's located underneath the radical. So if b squared minus 4ac is negative, tell me about your answer then. Imagine, he said not real, with a very heavy accent. Okay, so b squared is 1 minus 4 times 1 times 1. So that's 1 minus 4. So it's going to be negative. So are these answers real? So what do I do with that trinomial?
Cross it out.
Yeah, you can't do anything with it. It's imaginary. So I only have one candidate. So what do I do with that candidate? Plug that x value into the original function. So we want to evaluate f of negative 1. So we need to go back up to our original, which is right here. So it's negative 1 to the 4th power. So this is negative 1 to the 4th power plus 4 times negative 1. So what is that? Negative 3? Okay, so this is what you state. First of all, you knew, if you look up here in this table, that because this was a positive leading coefficient, even degree, I was only going to have an absolute minimum. So that's why we only got one candidate. So you have to make sure you state what it is, though. So you would say that f of x has an absolute minimum at f of negative 1 is equal to negative 3, or at negative 3, however you want to state it. But you need to make this statement here, because couldn't it also have been an absolute max, depending on the function? If the leading coefficient was negative, it could have been an absolute max. So you need to let whoever's reading this know that you know what it is. Does that make sense?
Absolutely.
Thank you. Okay, any questions on this one before we do the last one together? This is actually not that bad. It looks bad, but it's not. Here it says sketch the graph of a continuous function with the stated properties on the given interval. Okay, so we're going from negative 5 to positive 5. Okay, whatever happens beyond those two endpoints, don't care, right? So it has a definitive beginning and definitive end. Okay? So then f has a relative minimum at negative 3. So I'm just going to highlight some of this stuff. Relative minimum and a relative max at x equals 2, absolute min at 5, and absolute max at negative 5. That's a lot of information. I would focus on the absolutes first because those are where you're definitely going to have your highest and lowest points. Now, is it possible that Ben's graph is going to look different from Doriti's graph slightly? Yes. It just depends on where you plot your points. It is a choice. Okay, so here we have an absolute maximum at negative 5. So I'm going to go to negative 5. Here I am on the x-axis. Tell me what to do, please. This is your one shot. Tell me what to do. Yeah, I need to go up. Okay. Now, I also have a relative max. So is this good enough? I mean, it could be, but then my graph's going to be hard to sketch. True? Okay, yeah. So can I go here? Okay, fine. So we said that this is absolute max, right? And I'm just writing it for myself, and I'm going to check this off. What should I plot next?
Absolute min.
Okay, so I'm going to go to positive 5.
And then drop it down to the flow.
Is this the floor? Or as you say, the flow?
Sure.
Okay, so I'm going to plot here. Absolute min. Did you have to drop that point that far? No. Okay. Done. I have to be really careful what I say. Okay. Relative. Well, what do you want to do? Relative min or relative max? Okay, if we do relative min, okay, so it's.
That's gold.
If we do relative min at negative 3, okay, tell me what to do.
Go down.
Okay, if I go down, that could be a relative min, right? Okay, I'm just going to make a little mark there. You see it? Then a relative max at 2, could it be right here? Yeah, I mean, it's going to make my graph look really weird, but you want to make them distinct if you're sketching a graph. So if I make this right here, which is my relative min, my relative max, I don't know, right here maybe? As long as it's higher than the relative min. Okay? So you notice I was exaggerating. So that means when I sketch my graph, I don't know, maybe
One question, is that supposed to be negative 6 or negative 5?
negative 5.
On below the x-axis, that one.
It doesn't matter because it's at x equals 5. It doesn't matter. They, according to Mr. Cassidy, I had to drop it to the flow. So that was the flow. I think you missed that. Does that satisfy all of the characteristics that were given?
I believe that is.
Do we have questions?